Hi guys, it's Jack here. In this video we're going to factorise some quadratics, and in the questions 6 and 7 there's going to start being numbers in front of the x squared, so the a coefficient. So feel free to skip to the question you're after with the time in red.
Question 5. Now this is a personal favourite of mine, this topic. We're going to be factorising quadratics. So we have two examples here. Let's just first look at what this word is, quadratic. So previously you might have been dealing with linear lines, which the highest power of an x is 1. So you might have had, say, y equals 3x plus 1. Then you might have gone and graphed that and see what it looked like. Now we're looking at quadratics and we have an x to the power of 2. So basically quadratics is just a fancy way of saying the highest power in your formula is 2. Now a linear line you would have dealt with a straight line. These quadratics, like this one here, will be a curved line, like a smiley face or a frown face. But we're going to be dealing with sketching them later on. Okay? So, how to go about factorising these quadratics? Well, guess what? I've got a very nice method. It's called the Fox family method. It's a bit of a secret method, passed down through generations in our family. Got passed along by our dad when we were in school, I think in year 9, and it is a foolproof method of factorising quadratics. So you're in for a treat today. Now, let's what is the form of a quadratic? You probably have seen this in your textbook. A quadratic is in the form ax squared plus bx plus c. Okay, so using this first example, now you should do this every time. On the right hand side of your page, a is 1, because when you have x squared, that's the same as 1x squared. B is 7, and c is 6. Okay, now here comes the Fox family method. That's the first step. The second step is to draw this diagram. 2 boxes. From there, you're going to draw 2 lines out, and we're going to be writing some numbers on top of these lines. Now, this box here on the left will be a times c, and this box here down below will be b. Now, I want you to put a times sign here and an addition sign there. Now, when you're at home, practice this a few times. I want you to commit this to memory. Okay, now let's go put these numbers in the box. We've got a times c, so inside this box will be 1 times 6. And this b here will just be 7. Now, what are we doing with this times and addition sign? Well, we need to find 2 numbers that we're going to be writing on top of these lines that will times to give 6 and add to give 7. Okay? So 2 numbers. Well, let's look at numbers that times to give 6. You got 3 times 2, and you have 6 times 1. Now, will 3 and 2 add to give 7? No, that adds to give 5. What about 6 and 1? Spot on. There we go. So our 2 numbers here will be 6 and 1. Next step you do, you just write x plus this number here. And same for this one, x plus 1. And there are our 2 brackets. So our final answer will be x plus 6. You bring them together, x plus 1. So we have factorised this quadratic into bracket form pretty easily using this Fox family method. Let's go and have a look at the second one now. Let's write out our numbers on the right. So you have a equals 1 again. And in the next question, we're going to look at how to do it when a equals a number not 1. You use the same method, and question 6 will deal with that. B is minus 2, and you have C equals 1. So let's go draw up a diagram. Now I've done this so many times I can do it in my sleep now. B. Let's put our times here and our addition here. Now we're going to have A times C. So 1 times 1 is 1. And for B is minus 2. So let's look at numbers that will times to give 1 and add to give minus 2. So if we have let's look at all the numbers times to give 1. I actually had a bit of a stumble there myself. I forgot about this one here. So if you have -1 times -1, you're going to get 1. A negative times a negative is a positive. And that also adds to give -2. So we're on track there. So let's put our bracket now. Now notice here I did x plus 6. Whatever this sign here is the sign in front of this. So if this is 6, it's positive 6. This one is -1. So we're going to have x minus 1. And this one here will also be x minus 1. So our final answer will be x minus 1, x minus 1. So there we go. Fox family method. Now we're going to be doing this quite a bit over the next few questions, but there's the introduction to it. Now just as a side note, this x minus 1, x minus 1, it is the right answer, but we can go one step further. They're both the same. They're both the same term, so we can write that as x minus 1 all squared. Question 6, we're factorising again. This is going on from what we did in question 5. Now in question 5 I gave quite a detailed description on how to do the Fox family method of factorising quadratics. So if you haven't seen that one, have a look, and I'll go and solve these two questions, which are slightly different. Like for example here we have an a of 2, not 1, and for this one here we have a fraction where we're going to have to factorise the top line and then simplify later on. So have a look at question 5. And then from there we'll go on and have a look at these two questions. Okay, so let's recap. We have the form of quadratic is ax squared plus bx plus c. Now remember the first step, we're going to write our a, b's and c's. So a is 2 this time, b is 14 and c is 20. Let's go and draw a diagram up. I'm getting quite good at doing that one. A times C, 2 times 20 is 40. And B will be just 14. So now we need to find two numbers that times to give 40 and add to give 14. Well, this is a bit of an easy one, this one. I'm not going to go through all the combinations because I know that 10 times 4 is 40 and 10 plus 4 is 14. So I can go ahead and write 10 and 4. Now, here's where it's different when you have an A which is not 1. So instead of writing just x, you're going to write what a is. It's going to be 2x plus this number, 10. And you're going to also do it for the second one, 2x plus 4. Now, not quite finished yet. Here's the trick when your a is a number apart from 1. You need to divide one of your brackets, either one, by a. Now, usually it's pretty obvious which one you want to divide by because it'll work very easily and give you a whole number. In this example here, both are fine, but you only have to divide by 1. I'm just going to use the top one. I could have done the bottom one if I wanted. So I'm going to divide the whole fraction by a. So now, this one here, I'm going to jump this straight down here. 2x plus 10 all divided by 2 will leave me with x plus 5. I've divided both terms by 2. And you leave the other one the same. So there's the trick. And this is our final factorised answer. Okay, second one over here. This is a fraction with a denominator which is x minus 9. So the trick to this one is factorising the top line and then simplifying from there. So I'm just going to keep this aside for a bit. I'm just going to look at x squared minus 3x minus 54. So let's write it up. A equals 1, B equals minus 3, C equals minus 54. Let's go and draw a diagram up. A times C, B, line, line. This is particularly good for all the visual learners out there, like I am. So A times C is minus 54. I've got a thick pen, not much room to do it with. And this one will be minus 3. So two numbers, if you can't see, that's minus 54. Get a bit more room. It's my dog in the background, if anyone's wondering who's barking. Okay, so you have two numbers that will times to give minus 54 and add to give minus 3. I'm not going to go through, you're going to need to practice this step. I can already see, I've done a lot of practice with this, I can already see my two numbers will be minus 9 and 6. So get good at that. I recommend that probably writing out all the combinations of timesing. So 54 times 1, obviously 9 times 6, and so on and so on. And then looking which one of these will add up to give your B. So I have an A of 1, so I can just write it as x minus 9. And I have x plus 6. So my answer, when I'm factorising just the top line, will be x minus 9, x plus 6. Now I'm going to bring back in the denominator. So let's put it all over what we had. And look at this, look how perfect this has worked. We have a top line which has a bracket of x minus 9 and also a bottom line with a bracket of x minus 9. So I can go and cancel this. So my final answer just leaves me with x plus 6. Question 7, we're doing 2 more really just practice questions on how to factorise quadratics where A does not equal 1. So A here is 3, A there is 18. I actually explained how to do this on question 6 on the left hand side. So if you want to go and have a look at that, I went through it quite slowly. I'm just going to go ahead and solve these now, how I would solve it using the Fox family method. Okay, so let's write out my numbers. Let's firstly write the form of a quadratic. You should always do this. Let's go write our numbers out. A equals 3, B equals 10, C equals 3. Let's go draw a diagram. Times plus 2 numbers. A times C, we've got 3 times 3 is 9. We've got B is 10. So, 2 numbers to times to give 9 and add to give 10. Okay, so let's look at, this might be a simple one, but I'm going to go through the process I would do. What are all the numbers that can times together to give 9? Well, 9 and 1, 3 and 3, and that is it. So, which of these add to give 10? 9 and 1. Cool. Now, as I said in question 6, when I have an A of 3, you write 3x plus 9, and here 3x plus 1. Now remember in question 6, I now need to divide one of these 2 brackets by A. And I said in that example that usually it's clear which one to do it. Just in that one it wasn't so clear I could do it in either. But I'm going to divide one of these 2 brackets by 3. So this one here at the top will give me nice whole numbers. If I did the bottom one, I'd end up with a third, and I'm not overly keen to do that. It would give me the right answer, but this one just looks a bit prettier. So I'm going to do 3 here. So the answer, the end result of this will be x plus 3. So x plus 3, and then 3x plus 1. There we go. Next one over here, a bit of bigger numbers, but that's alright. A equals 18, B equals 27, C equals 10. Let's go draw it up. I really enjoy watching the students that I've tutored draw these diagrams up, because I know that they're going to be getting these questions, which a lot of kids don't get full marks for. I know they're going to be getting full marks. A times C is 180. B is 27. Bit hard numbers, this one here. Okay, so thinking caps on. I need 2 numbers which times to give 180 and add to give 27. So how would I go about doing this? I'd probably write out the numbers which times together to give 180. So 180 times 1. Well, that's not going to be right, because adding those numbers will get 181. 60 times 3 will. That won't be there. I know that, what else? 30 times 6. But adding those will give me 36, not 27. I'm getting close though. Well, if that's 30, this will be 15 and 12. And 15 plus 12 is 27. There we go. So as soon as you get it, you can go ahead. 15, 12. Now I need to write, let's squeeze for room here. A is 18. Actually, I'm going to rub this out for now, just so I have enough room. And I'll rub that out as well. So this here will be 18 x plus 15. And this one here will be 18x plus 12. So I now need to divide one of these two brackets by 18. Now I'm going to get a fraction regardless of which one I choose, but if I choose the bottom one, I'll end up with a bit of a nicer answer than the top one, because 12 divided by 18 will end up with a prettier answer than 15 over 18 after I simplify. So I'm going to choose to divide this one here by 18, and that will get me, well, I'm going to first write this one here, 18x plus 15. That's up from here. And 18x divided by 18 will just be x, plus, now 12 over 18 simplified ends up just being 2 over 3. So notice how this method is really, really good to get out in brackets, because if I didn't know this box filling method, how the hell would I get from here to here? Well, that's especially with a fraction in it. So this is why this method is so neat.